Hi guys, welcome to my channel. In this video, I will be covering what are various error detection methods in data link layer. I will explain all these methods in detail. Guys, I have uploaded complete computer network subject tutorials. I will provide that link in description. You can watch from there. If you are watching this video for the first time, don't forget to like, share and subscribe to my channel. Let's get started. Before explaining various error detection methods, at first you need to know what is error detection. Error detection is the process of identifying errors in data transmission. For example, sender will send data like hello. For example, let us say hello binary code is 10111010. For example, whenever sender sends data, due to some noise and interference, this last bit 0 is converted to 1. As there is bit change, receiver may receive wrong data like HELLI. In place of O, receiver will receive data I, which is wrong message. So what are the bits that are changed due to noise in data transmission? We need to identify the bits. We call this process as error detection. As there is only single bit change, we call it as single bit error. Yes, for example, due to noise, so many bits are changed. For example, 1 is converted to 0 and again 0 and again this 1 is converted to 0, 1 and again this one 1 and 0, 1. If so many bits got changed due to noise, then we call it as burst error. So error detection is the process of identifying errors in data transmission. Error detection will make sure that receiver data is same as the sent data. And this error detection is done by using various techniques like VRC, LRC, Checksum Method and CRC. Guys, before explaining various methods, at first you need to know what is redundancy. Guys, for example, our data is 10111011. This is our data. Along with our data, we'll add some extra bits. Like, for example, I will add 1011. Guys, we also call these extra bits as redundant bits. By using these extra bits, we can detect and as well as we can correct errors in data. So redundancy is nothing but adding extra bits to our data. These extra bits are used to detect and as well as correct errors. Guys, for example, sender want to transfer this data. Guys, sender computer contains generating function. Generating function is nothing but it is an algorithm. So whenever data is given to generating function algorithm, then automatically generating function will create extra bits based on our data. So actual data and as well as extra bits, both are combined and then sent to receiver. And whereas receiver computer contains checking function, it is also an algorithm. By using extra bits, checking function will identify whether data is received correctly or not. If data is received correctly, then checking function will accept data, or else checking function will reject data. Redundancy means extra bits added to our data. By using that extra bits, receiver will identify whether data is received correctly or not. Error detection methods are classified into 4 types. And the first one is vertical redundancy check. Shortly we call it as VRC. Guys, we also call VRC as parity check method. VRC method will identify errors by adding extra bit to our data. So VRC is a simple error detection method where an extra bit is added to our data. We call this extra bit as parity bit. I will explain VRC with an example. Yes, for example, sender want to transfer data, that is 11000001. If there are odd number of ones in our data, then VRC value is 1, and if there are even number of ones in our data, then VRC value is 0. If you observe this data, total there are 3 ones. So 3 ones, which is odd number. As there are odd number of ones in our data, VRC value, that is 1 is added to our data. We call this extra bit as parity bit. So in VRC, parity bit, that is 1 plus our data, that is 11000001. Both are combined and then transferred to receiver. This is sender data and receiver will receive data like 1, which is parity bit, and 11000001. This is data which is received by receiver. Now based on this parity bit, receiver will identify whether data contains errors or not. As sender's data contains odd number of ones and we are adding extra bit, that is 1 to our data, as receiver receives both parity bit and as well as actual data. Now here count will be even number of ones. Total there are 4 number of ones, 1, 2, 3, 4. If sender data contains odd number of ones, then receiver data must be even number of ones. If receiver receives data with even number of ones, then data is correct. Receiver got data without any errors. Just for example, actual data is 11000001, which is actual data. But due to some disturbance and noise, receiver received data like, in place of 0, receiver receives data like 1. So in place of 0, receiver got data 1, which is wrong data. Now receiver will count ones. Total there are 1, 2, 3, 4, 5. 5 ones. As sender data contain odd number of ones and receiver's data also contain odd number of ones. As receiver got odd number of ones, receiver will know that data is wrong data. So VRC can detect single bit error. Guys, VRC method can detect only single bit error. If multiple bits are changed in data, then we call it as brushed error. VRC cannot detect brushed errors. Just for example, now multiple bits got changed. For example, sender data is 1100001. But here, in place of 1, receiver receives data 0. And similarly, in place of the 0, receiver receives data 1. Actually here, 2 bits got changed. This one and as well as this one. So even the 2 bits got changed. So whenever receiver receives data, receiver will count ones. As sender data contain odd number of ones, receiver count must be even number of ones. Now if you observe count 1, 2, 3, 4, which is even number. Though 2 bits got changed, receiver count is even number. So receiver will think that there are no errors in data, but actually 2 bits got changed. So VRC method cannot detect brush errors. This is an algorithm for VRC. So in sender side, sender will count a number of ones in data. If number of ones is even number, then parity bit value is 0. If number of ones in our data is odd number, then parity bit value is 1. So actual data and as well as parity bit value, both are combined and then data will be transferred to receiver. Now receiver receives data and as well as parity bit. And even in receiver side, receiver will count a number of ones. As sender's data contain odd number of ones, so receiver count must be even number of ones. If there are even number of ones in receiver side, data is correct, else then data is wrong data. As in VRC method, in sender side there will be algorithm called even parity generator. Whenever data is given to this algorithm will automatically count the number of ones, and based on count, this even parity generator will generate parity bit, that is 0 or 1. Yes, for example, in sender data, there are 2 ones, which is even number. So whenever data is given to even parity generator, as our data contain even number of ones, so parity bit 0 is added to our data. So our data and as well as parity value, that is 0, both are combined and then transferred to receiver. Thus here, there are even number of ones. So whenever extra bit 0 is added to our data, and even in receiver side, number of ones must be even number. So whenever parity bit 0 is added to data, both sender side and as well as receiver side, both side count must be even number of ones. For example, in place of 0, receiver will receive data 1. Now receiver will count number of ones. Total there are 3 number of ones, which is the odd number. Now receiver will understand that data contains errors. So whenever parity bit 0 is added to data, both receiver side and as well as sender side, both count must be even number of ones. Next I will explain what is LRC, where LRC stands for Longitudinal Redundancy Check. Guys, if you consider VRC cannot detect brushed errors. Brushed errors mean if multiple bits got changed in data, VRC cannot detect brushed errors. And whereas if you consider LRC can detect brushed errors. Thus in LRC, we will arrange data in the form of rows and columns. I will explain LRC with an example. Thus for example, there are multiple blocks of data like 1110011 and similarly 1101101 and 0011101 and 1010101. These are various data blocks which sender want to send to receiver. Whenever sender want to transfer data to receiver, along with our data blocks, sender will add some extra bits to our data. We call that extra bits as LRC. So sender will send data and as well as LRC that are nothing but extra bits. Based on this LRC, receiver will identify whether data contains errors or not. And whereas in LRC, at first we will arrange data in the form of rows and columns. These are data blocks. Total there are 4 blocks of data. So 1, 2, 3 and 4 blocks. So first block contain values 1, 1, 1, 00 and 111. And similarly second block contains 1, 1, 0, 111, 01. And third block contains 00, 111, 001. And fourth block contains data, that is 10, 10, 1, 001. These are our data blocks. Now we arranged our data in the form of rows and columns. Now we need to add LRC to our data, the same formula which we applied in VRC. If there are odd number of ones in our data, then LRC value is 1. And if there are even number of ones in our data, then LRC value is 0. And we need to calculate it column wise. So first column contains 1, 2, 3, 4. 4 ones, which is even number. So we need to add 0. And next column contains 1, 0, 0. As there is only 1, which is odd number. So we'll add 1. And next here 1, 1, 0, 0. 2 ones. 2 is even number. If there are even number of ones, we'll add 0. And similarly here 3 ones, which is odd number, we'll add 1. 2 ones, even, we'll add 0. And here 3 ones, which is odd number. So we'll add 1. And next here 2 ones. So we'll add 0. And again here 3 ones, which is odd number. So we'll add 1. So now we got LRC value. Now both LRC value and as well as data, both are combined and then transferred to receiver. This is LRC value plus data. Both are combined and then transferred to receiver. So whenever receiver get this data, receiver will separate LRC and then receiver will again calculate LRC. Yes, same way. How sender calculated LRC, in same way receiver will calculate LRC. After calculating LRC, if sender's LRC and as well as receiver's LRC, if both values are equal, then receiver got correct data or else receiver got wrong data. That means receiver data contains errors. This is all about LRC. Yes, for example, first block contains data like 111, 00, 111. But whereas in receiver side, at last, here in place of 1, receiver will receive data 0. So your last bit is 0. And similarly, in second block first bit, in place of 1, receiver will receive 0. So in second block first bit, receiver got 0 in place of 1. Now in receiver side, receiver will calculate LRC. Previously data contained 4 ones, which is even number. But as 1 is changed to 0, now data contain odd number of ones. So we'll include 1. And previously here, there are odd number of ones. But here data got error. That is 1 is changed to 0. If you observe count, there are even number of ones. So 1 is changed to 0. And whereas sender data is 10, 10, 10, 10. But whereas receiver data is 00, 10, 10, 11. So receiver will identify that data contains errors. As sender's LRC is not equal to receiver's LRC, now receiver will know that data block contains errors. As if you observe here, multiple bits got changed. That is nothing but data contains brushed errors. So if there are brushed errors in data, LRC can identify that errors. Yes, there is one problem with LRC. That is, LRC will not detect errors if 2 bits are changed in same column. I will explain with an example. Yes, for example, if you consider this column, here there are 2 ones. As there are 2 ones, which is even number, so extra bit added is 0. But due to some noise in data transmission, the 0 is changed to 1 and 1 is changed to 0. So if you observe here, 2 bits got changed in same column. Now if you count, total there are 2 ones, which is even number, so still value is 0. Even though data got error, still our value is 0. So whenever receiver receives data, receiver will think that there are no errors in data, but actually data contains multiple errors. So LRC cannot detect errors if 2 bits got changed in same column. In LRC, our block of bits are organized in rows and columns. So we can also call LRC as 2-dimensional parity. As LRC is old network protocol. Now LRC is replaced with CRC, where CRC stands for Cyclic Redundancy Check. Next I will explain what is checksum method. Guys, by using checksum method, we can identify errors in transmitted data. Yes, for example, our complete data is divided into various blocks. After dividing our data into various blocks, we need to perform binary addition between these blocks. After performing binary addition between these blocks, we will get one result. We call this result as checksum. So data and as well as checksum, both are combined and then transferred to receiver. Based on checksum, receiver will identify whether data contains errors or not. I will explain with an example. This is how checksum will work. And the first step is, we need to divide our data into fixed size blocks. I am selecting size 4. Each block will contain 4 bits. This is block 1, block 2 and block 3. After dividing our data into fixed size blocks, next step is, we need to sum up all the blocks. That is nothing but, we need to perform binary addition between these blocks. Guys, I will explain what is binary addition. In binary addition, 0 plus 0 means 0, 0 plus 1 means 1, and 1 plus 0 means 1, and 1 plus 1 means 0, and where 1 is carry. I will explain what is carry. and whereas 1 plus 1 means 1, which is sum and which is carry. This is binary addition table. Guys, by using this table, now we need to perform binary addition between these blocks. So first block contain 0, 1, 0, 1 and second block contain 1, 0, 1, 0 and third block contain 1, 1, 0, 0. 1 plus 0 plus 0, as there is only single 1, 1 plus 0 plus 0 is 1. And similarly here, as there is only single 1, 0 plus 1 plus 1 is 1. And similarly here, 1 plus 0 plus 1. If you observe here, there are two 1s. If there are two 1s, then sum is 0 and carry is 1. So 1 plus 0 plus 1 is nothing but 0, 1 is carry. And similarly again, 1 plus 0 plus 1 plus 1. Total there are three 1s. If there are three 1s, then sum is 1 and carry is 1. So sum is 1 and carry is also 1. Guys, each block contain only 4 bits. So our checksum also must be 4 bits. But if you observe this result, checksum contain 5 values, which is wrong. So we need to remove this one and we need to add this one here. So again we need to perform binary addition, that is 1 plus 1. So 1 plus 1 means 0 and where 1 is carry. And again 1 plus 1, that is 0, 1 is carry. And again 1 plus 0, as there is only single 1, result is 1 and at last 1. Now there are only 4 bits. This is how we perform binary addition. After summing up all the blocks, third step is we need to perform 1's complement of the sum. This is our sum. Now we need to perform 1's complement. 1's complement means zeros will become 1 and 1's will become 0. So 1 will become 0, 1 will become 0 and 0 will become 1 and 0 will become 1. This is known as 1's complement. After performing 1's complement, final result which we call it as checksum. This is our data. So data and as well as checksum, both are combined and then transferred to receiver. Whenever receiver receives data, again receiver will perform binary addition including this checksum. So our data is 0, 1, 0, 1, 1, 0, 1, 0, next 1, 1, 0, 0 and as well as checksum, that is 0, 0, 1, 1. Yes, after performing binary addition, if result contain all 1s, then there is no error. But if result contain any 0 bits, then our data contains error. Now we will perform binary addition. 1 plus 0 plus 0 plus 1. So 1 plus 1 is nothing but 0 and where 1 is carry. So 0 and this 1 is carry. Now again 1 plus 0 plus 1 plus 0 plus 1. As there are 3 1s, so 1 plus 1 plus 1 is nothing but 1 1 where 1 is sum and next one is carry. Again if you observe here 3 1s. 3 1s mean 1 is sum and next one is carry. And again if you observe here 1 plus 0 plus 1 plus 1 plus 0. Total there are 3 1s. So 1 plus 1 plus 1 is nothing but 1 and 1 is carry. Guys, here also we got 5 bits. But as our result contains 4 bits, this sum also must contain 4 bits. So we need to remove this one and we need to add here. Again we need to perform binary addition. So 0 plus 1, that is 1 and no value is 1 and again 1, 1, 1. My result contains all 1s. So there is no error in our data. Yes, for example, receiver got error, like here in place of value 1, receiver got 0, as receiver got wrong data. Now again we will perform binary addition in order to check errors. So first value is 0, 1, 0, 1. And next value contain 1, 0, 1, 0. And third block contain 1, 0, 0, 0. And fourth block contains 0, 0, 1, 1. Guys, there are 2 1s. So 1 plus 1 is nothing but 0 and 1 is carry. And if you observe here, there are 3 1s. So 1 is sum and next one is carry. And similarly again 1 plus 1 plus 0 plus 0 plus 0. So 1 plus 1 is nothing but 0 which is sum and next one is carry. And 1 plus 1 plus 1. Total there are 3 1s. So 1 is sum and 1 is carry. As there are 5 bits, remove this one and add this one here. So 0 plus 1, 1 and 0, 1. We got result as 0. Whenever sum is 0, then receiver will understand that data contains errors. Only if all values are 1s, then there are no errors in data. If any of the bit contains 0, then receiver will understand that data contains errors. Whenever sender send data plus checksum to receiver, then receiver will add all the blocks and as well as checksum. If sum contain all the 1s, then there is no error. Otherwise, data contains errors. This is an algorithm which shows how checksum will work. Next I will explain what is CRC. Guys, CRC stands for Cyclic Redundancy Check. I will explain CRC with an example. Yes, for example, sender want to send data, that is 100 100, and in CRC method there is divisor. This divisor is known to both sender and as well as receiver. So this value is known to both sender and as well as receiver. Based on this divisor, sender will calculate CRC value. Where CRC is nothing but CRC is extra bits added to our data. By using these extra bits, receiver will identify whether data contains errors or not. Guys, we will calculate CRC based on XOR table. For XOR operation, if both values are same, then result is 0, result is 1. So for 0, 0, result is 0, and for 1, 1, result is 0. And for 0, 1, result is 1, and for 1, 0, result is 1. Based on this table, now we need to calculate CRC. Because divisor is 1101 and our data is 100 100. If our divisor contains 4 bits, then we need to add 3 zeros to our data. So we need to add extra 3 zeros to our data. If divisor contains 5 bits, then we need to add 4 zeros to our data. For example, if divisor contains 6 bits, then we need to add 5 zeros to our data. As divisor contains 4 bits, I am adding 3 zeros to my data. So first time we will apply XOR operation. First time I will divide. So 1101. And for these values, we need to apply XOR operation. For XOR operation, if both values are same, result is 0. So for 1, 1, result is 0. And for 0, 0, result is 0. And for 0, 1, result is 1. And again for 1, 1, result is 0. Guess 0, 1, 0, 0. As the last value is 0, so need not to consider it. We can remove the 0. We need 4 bits, as there are only 3 bits. Now I will add the 0. Now there are 4 values. Again we need to divide. So 1, 1, 0, 1. Again we need to apply XOR operation. So for 0, 1, 1. For 0, 0, 0. For 0, 1, 1, 0. So 0, 1, 0, 1. As the last value is 0, you can remove it and you can bring this 0. So 1, 0, 1, 0. Again we will divide 1, 1, 0, 1. So 0, 1, 1. 1, 0, 1. 0, 1, 1. And 1, 1, 0. As the last value is 0, you can remove this and you can add this 0. So now there are 4 bits. Again divide. So 1, 1, 0, 1. So 0, 1, 1, 1, 0, 1. For 1, 1, 0 and for 1, 1, 0. As last 2 values are zeros, you can remove these 2 and you can add these 2 zeros. So 1, 1, 0, 0. Again divide, that is 1, 1, 0, 1. So for 0, 1, 1. For 0, 0, 0. For 1, 1, 0. And again for 1, 1, 0. Guys, divisor contains 4 bits. So we added 3 zeros. So even for CRC, we need to consider last 3 bits. So 001 is my CRC code. Now our data and as well as CRC code, both are combined and then transferred to receiver. So now both data and as well as CRC code, both are combined and then transferred to receiver. Guys, I already said before, this divisor is known to both sender and as well as receiver. And again receiver will perform XOR operation by using this divisor. So receiver performs XOR operation for this complete data, including CRC code. Now we will apply CRC for this entire code. So 100, 100, and 001. And our divisor is 1101. So one time we will apply divisor, that is 1101. If both values are same, result is 0. So for 110, for 000, for 011, and for 110. As last bit contains 0, you can remove this and you can add this 0. Again apply divisor 1101 for 011, for 000, for 011 and for 110. As last value is 0, so remove this and add this 0. 1010, again apply 1101. So for 011, for 101, for 011, for 110. As last value is 0, no need to consider this, remove this and add this 0 and again apply 1101. So for 011, for 101, for 110 and for 110. As last 2 values are zeros, you can remove this and you can add these 2 values, that is 0 and 1. So 0 and 1 and again apply 1101. Both values are same, in result is 0. So 0, 0 for 110 and for 110. As all values are zeros, then receiver will understand that data received is correct data. As sender data is 100, 100. And receiver also got data, that is 100, 100. So data is correct data, that is why we got all bits as zeros. Yes, for example, in place of 100, 100, If receiver receive data like 100,101, in place of 0, if receiver receive 1, whenever receiver perform the same XOR operation, then receiver will receive 1 bit as 1. So whenever receiver receive bit 1 in data, receiver will understand that data is wrong data. So receiver got data that is 100,101. In place of 0, receiver got 1 and our CRC code is 001. So 1101. So one time I am applying 1101. So both values are same 0, 0 for 0, 1, 1 for 1, 1, 0. Remove the 0 and add the 0 and again 1, 1, 0, 1. So for 0, 1, 1 for 0, 0, 0 for 0, 1, 1 and for 1, 1, 0. Again last value is 0. So remove this and add this one 1, 1, 0, 1. So both values are same 0, 1, 1, 0. Again remove the 0 and add this 0. So 1, 1, 0, 0. Again 1, 1, 0, 1. So 1, 0, 0, 0. So remove this value and add these two values 0, 1. So 0, 1, 0, 1 and again apply 1, 1, 0, 1. So for 1, 1, 0, for 0, 0, 0, for 1, 1, 0 and if you observe here for 0, 1, 1. Only if receiver receives all zeros, then data is correct. Else if receiver receives any bit as 1, then data is wrong data. As in place of 0, receiver got 1. So here we got result as 1, which is wrong data. So by seeing this result, receiver will understand that he got wrong data.